Okay, so today's lesson is about something called sample spaces and the counting principle. So our first objective, we're going to talk about what sample space is. We are going to create our sample space, and we're going to use the counting principle. Counting principle is super easy, so you're going to like when we get there. Sample space, not difficult, it just takes a lot of work sometimes. Whoops. Okay, a sample space is just the collection of all possible outcomes in an experiment. It is helpful to use a table or a tree diagram to determine the sample space. So a sample space is when two things are happening at the same time. It can be hard to keep track of how many outcomes there are. For example, if we're finding the sample space for rolling 2 number cubes, there's lots of possibilities here because we have 6 numbers we can roll on one cube plus the 6 numbers we can roll on the other cube. So we could roll like a 1 and a 1 and a 1 and a 2. We could roll a 3 and a 6. There's a lot of possibilities. So to make sure we get them all, we use a table. And what we do is we're going to put the sample space for one cube across the top. So when you roll a cube, the possibilities are 6 different numbers. You could roll a 1, a 2, a 3, a 4, a 5, or a 6. And I'm going to draw lines to divide them all. Now, along this side, I'm going to write the possibilities for my other number cube. So for my other number cube, I could also roll a 1, a 2, a 3, a 4, a 5, or a 6. I'll draw one more there just to make it. Okay, so now I can organize all of my possibilities. First possibility is I could roll a 1 on the first cube and a 1 on the second cube. So I could have a 1 and a 1. Then I could have a 1 on the first cube and a 2 on the second cube. So I could have a 1 and a 2. I could have a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. What do you think I would write right here? Jonathan, what would I put in this square?
Oh, 2, wait, would it be 1 and a 2 or 2 and 1?
I'd start with the 2. I usually start with the horizontal first. So 2 and a 1. Brooke, what would I put in this space? I want to go here and here. Brooke, I want to put my number from over here. So I want this number and this number. So over here we have, what's this number right here?
3, 2.
So what's this number? Can you see it? Well, there's 2. Comma. Same number. 2. Addison, what would I put here?
2 and 3.
A 2 and a 3. So I'm going to put my 2 from over here and my 3 from over there. Okay, you get the idea about how you're going to fill this chart out? Okay, we're going to take a second. I want you guys to finish filling it out. Don't necessarily watch me and just try to copy what I have out here. You finish filling out the chart on your own. I'll finish filling it out up here, and then you can glance up to compare notes on this. Okay? I'm going to pause this for just a minute. Okay, so the video is paused for a second. I filled in the whole chart, so that anyone watching the video, you might want to just pause it now so you can look at this, finish filling in your chart if you need to. But the important thing is that you understand what we're doing here. So it asks us, here's the reason we made the chart. It asks us to find the probability of rolling at least 1 3. So that's right here. Find the probability of rolling at least 1 3. So we're going to look in our chart and we're going to see how many of the outcomes had at least 1 3. So that means we have to count it if there's 1 3. We also have to count it if there's 2 3s, because at least 1 3 means there could be more than one. So I'm going to use a different color. I'm going to switch to, let's see, how about blue? And I'm going to circle all of the outcomes that have at least 1 3. So all of them in this column with 3 are going to have a 3. And then also all of them in the row with the 3 are going to have a 3. So that makes them kind of easy to find. So we'll end up with this plus shape on there. Now, in order to find the probability of rolling at least 1 3, we just count up how many were circled, how many had at least 1 3, out of how many there are altogether. Akasha, how many do we have circled up there? 11. So we have 11 circled. And can anyone tell me how many numbers are in the whole thing? You could do some quick multiplication. Ben?
Hold on.
Thomas?
6 times 6.
6 times 6, which is?
36.
36.
That's
Okay,
so
the
easy.
probability of rolling at least 1 3 is 11 out of 36. No, it's not 12, because you don't want to count this middle one twice. You were kind of thinking about a shortcut like 6 plus 6, but this one you would end up counting twice.
No, I thought it was 12 3.
Still.
No, it's not paused.
2, 3, 4, 5, 6, 7, 8.
I know it.
Okay.
Getting calculated.
Okay, moving on. I'm going to have you try this. This is much easier. We're making a table for the sample space for tossing 2 coins. So when I made the table for rolling dice, I had 6 across the top and 6 along the side. How many am I going to have if I'm just tossing a coin? How many outcomes do I have for each coin? Ben's got it. He's showing me 2 fingers. So you're only going to
I'll show
have
it.
2 across the top. Now, you can use this as H for heads, T for tails. So across the top, we have the first coin, heads and tails. Across the side, we have the second coin, heads and tails. And then we're just going to fill in this table. This is much easier. We only have 4 slots. So pause the video, fill in the slots, and then check back to see if you did it right. Okay, so what would go in this first square up here? Thomas.
Heads, H,
Good.
H.
H. Hannah, what would I put here? Good, I'm taking my H from over here, my T from up here, so I have H, T. Akasha, what would I put here? Good, TH. And Ben, what would I put here? TT. Okay, so now it asks us, what is the probability of getting 2 heads? How many outcomes up here show getting 2 heads? Thomas?
1.
Just 1. We only have this one. So we have 1 possibility out of how many?
2.
No, how many? Yeah, we've got 4 possibilities up here. So the probability of getting 2 heads is 1 out of 4. Next thing is similar. Sometimes it works better to make what's called a tree diagram. Suppose you were going to travel on a river. You have 2 choices of boats, a kayak or a rowboat. You can go upstream to 3 smaller streams, to the north, northwest, and northeast. Now you could do a table for this, but I'm going to show you a tree diagram way to do this also. So first I'm going to write my 2 types of boats. So I'm going to put kayak, and then I'm going to put rowboat. And I have to be very careful to be neat up here so I don't run out of room. Okay, now, then I have 3 choices of what direction I'm going to go in. I could go north, I could go northwest, or I could go northeast. So when I'm in the kayak, I have these 3 choices. North, I'm just going to write N, northwest, or northeast. When I'm in the rowboat, I have those same 3 choices. I could go north, I could go northwest, or I could go northeast. So now I have a list of all of my different possibilities. I could be in a kayak going north. I could be in a kayak going northwest, or I could be in a kayak going northeast. Then I also have my scene 3 rowboat choices. I could be in a rowboat going north. I could be in a rowboat going northwest. And I could be in a rowboat going northeast. Okay? Okay, so these are all of the possibilities. This is our sample space, our list of possible outcomes. It says, what is the probability of selecting a kayak and going directly north? So out of these possibilities, how many include kayak and north? Addison? Just one possibility out of how many possibilities?
Just the kayak?
No, out of the whole list. 6. So the probability of selecting a kayak and going directly north is 1 out of 6. Okay. The next one is one for you to try. So let's take a look at this one. This one's actually kind of long, so we'll probably go kind of quickly through this. Suppose your sister is going to the store to buy candy. She has 3 methods of transportation: walk, ride bike, or ride scooter. She can choose from 3 different stores within walking distance: Walmart, Weis, or Giant. Draw a tree diagram. What is the probability that she will ride her scooter to Walmart? We're going to pause the video, give you guys a chance to draw your tree diagram, and then we'll come back and check. Okay, so this is all filled out for us now. Hopefully if you filled it out, you did it the same way. What is the probability that she will ride her scooter to Walmart? Let's see, Halen, how many possibilities are there of her riding her scooter to Walmart? You can just look up here, this list. Here's our list of outcomes. How many of them involve riding her scooter to Walmart?
1 over
1 out of how many choices?
9.
9. So the probability would be 1/9. Okay, one last thing that we have to fit in before the end of class, and this sounds a little complicated, but it's super easy to do. And that's called the counting principle. When you are making more than one choice, the number of possible choices is the product of the number of each choice. That sounds complicated, but you'll see how easy this is. So suppose you have 3 pairs of pants, 10 shirts, and 3 jackets. How many different combinations could you have? So when you're finding the product, what operation are you doing? What does product mean to do? Thomas? What do you do? Hannah, what do you do when you're finding the product? Do you add, subtract, multiply, or divide when you find the product? No? Anybody? Austin? You multiply. So finding the product means that we multiply. Okay? So all we're going to do is take these numbers and multiply them together, and that tells us how many combinations we have. So we have 3 pairs of pants, and each one of those pairs of pants could have 10 different shirts. So if we were drawing the tree diagram, we'd have a lot of choices here. And then times 3 jackets. So we have 3 times 10 is 30, and 30 times 3 is 90. So we have 90 different combinations if we have 3 pairs of pants, 10 shirts, and 3 jackets. So you could go through a good part of the year, you could go through a whole 4th of the year without wearing the exact same combination with this wardrobe. Pretty neat. Okay, the last thing that we're going to look at, and we'll just look at this quickly together, you are at a sub shop. The price for the bargain sub allows you to build a sub on a bun with 1 kind of meat, 1 kind of cheese, 1 veggie, and 1 sauce. Your choices for buns are white, wheat, or garlic. So how many buns do we have? 3. So we're going to take 3 we're gonna multiply it times our meat choices. Our meat choices are ham, turkey, roast beef, or tuna. How many was that?
4.
4, so we're gonna multiply times 4. Now we're gonna choose from American, cheddar, Swiss, or pepper jack. So how many cheeses is that?
4.
4. And then, let's see, we can pick either lettuce or spinach. How many choices is that?
2.
2. And then for sauce, we can have Italian, ranch, or mayo. So how many choices
3.
is that? So to find how many different subs we can create, we are going to multiply all of these together. 3 times 4 is 12. 12 times 4 is 48. 48 times 2 is 96. And 96 times 3 is 288. So imagine when you go to Subway, you have even more choices than this. It is really unlimited, the number of, not unlimited, but almost unlimited. It's a huge number of subs that you could actually create. Or when you go to like Sweet Frog frozen yogurt where you can pick, I gotta stop there.